pretty much the same thing, except it's after. What we know after the execution of a statement in a program. So that's the precondition and the post-condition of a statement. Now, the analysis of the pre and post conditions of the entire algorithm or the entire program is essential, because the precondition, okay, let me just kind of focus on this part here. The precondition of an entire program is basically your assumption before the program executes. What can we assume about the relationship between the variables before the algorithm starts? That's the precondition of the entire algorithm. The post condition is even more important, because it is a guarantee, and say when this algorithm completes, it is guaranteed that this condition has to be true. Okay? So if you can show that the post condition of an entire algorithm is in fact what you want the program to do, and you can prove it step by step, rigorously using mathematics, then you have just proven that your program is correct without the need of a single test case, without a single trace. Okay, so we'll be able to do some of that stuff, later on, when we talk about pre and post conditions. That's basically what I just mentioned here in the next paragraph. Okay, the last sentence is particularly important, because if we can prove the post condition to be correct, there's no need to use test cases anymore, because a proof of correctness will cover all possible cases, assuming a certain precondition. All right, so let's go ahead and start with some examples here. Okay, and I may not be using the same order as in the notes, but nonetheless, it is the same material. Okay, let's start with something that is completely confusing. Okay. Let's look at the statement. This is a statement within a program somewhere. So I'm going to say this is line 517. There are some other code in the program that I'm not focusing on. So let's say at this point, I say x gets the value of y. Okay, that's the only thing this line is going to do. If I say pre 517, this is representing the precondition of line 317, which is basically saying, regardless of the trace, regardless of the data and whatnot, if I ever get to line 517, this condition is guaranteed. It has to be true. Okay, that's what the precondition is about. Okay, it has to be true by the time we get to this line. All right. So let's say I know several things that has to be true. Okay, don't ask me why, because it has to do with the other lines of this program. But let's just make an assumption that we know that x has to be greater than z, and y has a value that is the same as k, and y, which we don't even see on this line, by to z. Let's say w is different from z. Okay, so we know all these things before line 517 executes. Did I say anything specific about y? Does y have a specific value? No. But this is guaranteed. Okay, whatever k is, y has the same value. Whatever z has, x is greater than that. Whatever w has and whatever z has, they are different. Okay. Yep.
This is all assuming line 1 through 516 are all debugged and perfect.
No. This is assuming that we can derive this precondition from some other reasoning. Okay. But the point is, this is guaranteed. This is guaranteed when we get to line 517. So the question now is, knowing this, what can we say about the condition after line 517 execute? Can we still guarantee that x is greater than z? No, because we don't know the exact value of y. We know that y equals k, but there's nothing to link it back to z. I have no idea whether the new value of x is going to be greater than z or not, so that one has to be gone. What about y equals k? Can we keep that?
Yeah.
We can keep it because we didn't do anything about y except to use it to copy to somebody else. So the fact that y equals k has to remain, true. What about the other one, w versus z? Did we do anything about W or Z? None whatsoever. So if they were different before, they have to be different at this point. Yep, go ahead.
X is also the same as K now.
X is the same as K. Exactly. So we do have to add one more thing and say, oh, guess what? By now we know that X equals to K. So this is what we are talking about when we talk about pre and post conditions. Okay, precondition is, for some reason, that can be proved rigorously, step by mathematics. This condition has to be true before that line executes. The post condition is, well, knowing what the precondition is, what can we guarantee after a particular line executes? Are we doing okay so far? Let me do this before I trip. All right. Let me give you another example. Okay, I'm not going through all the rigorous steps to prove anything, but I just want to show you all of these as examples. Line 65. So we'll do something a little bit more tricky this time. Okay, line 65 is x gets x plus 1. And the precondition of line 65 is, well, let's just say that x is less than k. Okay, that's all we know before line 65. Wow, that's a little bit difficult to say anything about post 65, right? Because we don't even know what x is, we don't know what x is, we don't know what k is. We just know that x is less than k. So the question is there anything to say as post 65? Yep.
X equals x plus 1.
No, you cannot say that, okay? Absolutely not this. You cannot say that like this because this is false. There's no way x can be the same as x plus 1. As a condition, right? As a condition, x equals x plus 1 has to be false. There's no value that can do that, okay? So what can we possibly say here?
X is less than k plus 1.
Exactly, okay? So what we are saying here is, well, look at the new value of x. Well, the new value of x is 1 more than what it was, right? But what it was less than k. So the other way to say this is, if I turn x back to its old value by subtracting 1, that would still be less than k. It has the same result as x is less than k plus 1, but the rationale is basically if I undo the effect of line 65, then I can still maintain the same relationship. Are we doing okay so far? Yep.
Theoretically, could you put x is less than or equal to k?
X is only if x is an integer and k is an integer.
Just
Yes. Yeah, if they're both integers, yes, you can say x is less than or equal to k in that case. But this will work regardless of whether it is an integer or not. Okay, so are we kind of doing okay with this? Okay, so we are trying to go from the precondition to the post condition and try to preserve as much information as possible. That's what we are trying to do. I cannot trace it because I don't know the exact value, but I can still work from the precondition and turn it into the post. Yep.
Now, because he had stated you could write it as x is less than k plus 1, and then you put it this way, is there any advantage to one over the other?
No, not really.
Okay, just write it down.
You can go either way. As long as I can see it, being equivalent, it'll be okay. All right. Are we doing okay so far with the concept of pre and post conditions? It's not tracing at all. Okay, not tracing at all. All right. So let's see if I can throw something even more, kind of sinister, and see if you guys can figure that out. Okay. Let's try this one. Okay, let's try 89. Let's try conditional statement. Okay, so if x is greater than or equal to k, then on line 90, say x gets x minus k, and then on line 91, have it ended here. Okay, and this time I'm going to say line 89 is I don't know anything. How can we say I don't know anything as a precondition? Now, I don't know anything as a precondition simply means I don't know anything. I don't know anything about x, its exact value. I don't know anything about y, k, in this case, its exact value. And I don't even know at this point how they relate to each other. In other words, x may be greater than k, x may equal to k, x may be less than k. I don't know any one of those facts, okay? So we'll just go ahead and say, what is one expression that has to be true even though I know nothing? It's a trick question. True, exactly. This expression has to be true, right? Because it is true itself. So when a precondition of a statement is simply true, all it means is we don't know anything. We know that we can get here, but we don't know anything else. Now, that by itself is important too. If the precondition of a statement is false, it means we cannot get there, regardless of any value of the variables that we're using in the program. If the precondition of a statement is false, it means we cannot get there. Okay, now that's important. We will later on we'll actually have cases, or I'll show you why we can have those weird cases. But in this case, it's true. Okay. Now, what about line 90? Can we say something about the precondition of line 90? In other words, if we ever get to line 90, which is the then branch of the conditional statement, what can we possibly say that has to be true? X is greater than or equal to k has to be true at that point, right? Okay, so x is greater than or equal to k has to be true, okay? And after that, is there anything we can say about post 90? X is greater than or equal to k. Well, in this case, we can only say something like this. We can only say that x plus k is going to be greater than or equal to k. That's all you can say, really. Because we are undoing this part here, so that x became the same value as it was before, and that value before was greater than or equal to k. Okay. What about post 91? Well, what is one quick way to get to line 91? Exactly, what the condition is false, right? So when we're on not line 91, we don't know how we got here. Okay, we're standing at a junction where those two branches merge, and we don't know which way we took to get here. So we can only say that, well, I guess this is one quick way to get here, but if we don't take the quick way to get here, then the other condition has to be true. Okay, so that's kind of the post condition of line 91. Okay, so don't worry about how to get these. It's very, very mechanical. Okay, so in for the rest of this week, well, this class, and also next week, we'll be doing this kind of thing. But at some point, I'm hoping that you guys will say, please, no more of this stuff. It is so boring because it is mechanical. Okay, I like everything to be mechanical because if something is mechanical, it can be rule-based. If it is rule-based, then it's only a matter of